Welcome back. Again, I'm Tom Field with Information Security Media Group, and I want to welcome you to this next session, which is entitled Crawl, Walk, Run, Your Segmentation Strategy. Your speakers today are Gustavo Nardelli, Business Development Executive, Data and Application Security Division with Illumio, Fabio Nunes, Senior Products Manager with Illumio, and Christer Swartz, Principal Technical Marketing Engineer, also with Illumio. A little bit of background on this session. While there are varying definitions of what zero trust actually is, there's one thing everyone can agree on. Segmentation is a key pillar. Another thing everyone can agree on, segmentation is hard. This presentation will highlight a way to begin your zero trust journey, leveraging enforcement boundaries that will enable you to protect your digital crown jewels as you work through your end-to-end zero trust plan. With that, let me turn you over to our trio of speakers. Folks, the stage is yours.
Bom dia, boa tarde, boa noite, dependendo de onde vocês estiverem nos assistindo ao redor do mundo. Eu, Gustavo Nardelli, recebo a todos vocês no Cyber Security Summit, capítulo Brasil, de 2021. Pelos próximos minutos, nós vamos fazer uma jornada pelo universo da microsegmentação com Illumio. A Illumio entendeu desde a sua fundação que a segurança deve ser um habilitador entre as aplicações e não um bloqueador. A Lidcom é uma Digital Security One-Stop Shop. Nós apoiamos as áreas de segurança de nossos clientes a alavancarem as áreas de negócio, garantindo assim a transformação digital segura. Preparamos esse material especialmente para vocês. Eu, Gustavo Nardelli, Fabio Nunes, estaremos disponíveis durante toda a sessão para esclarecer dúvidas e até mesmo depois, se vocês quiserem aprofundar um pouco mais no assunto. Participem e aproveitem.
O home office tornou essa cena mais corriqueira. Mas isso não é o fim do mundo. Temos uma solução. Empresas mundiais de pesquisa, como Gartner e Forrester, apontam que adotar uma abordagem Zero Trust reduz a exposição ao risco de cyberataques como ransomware e muitos outros. No modelo operacional atual, com funcionários trabalhando remotamente, a necessidade de uma abordagem Zero Trust é ainda mais urgente. Conheça nossa solução, Illumio. 45 segundos. Esse é o tempo que leva para um ransomware derrubar uma grande empresa. Todos os dias, vemos notícias sobre empresas sendo atacadas. Não porque elas não tenham o melhor detector de ameaças ou segurança. Não. É por causa de pessoas como você e eu. Vamos falar a verdade. As pessoas nem sempre pensam em segurança. Adiam a atualização de seu sistema operacional e clicam em links suspeitos, quando não deveriam. Inevitavelmente, uma invasão está fadada a acontecer. Um bom detector de ameaças não é suficiente. Ele pode esquecer uma peça-chave do quebra-cabeça. Como impedir que o ransomware se espalhe, como um incêndio. É por isso que o Illumio Edge está mudando o jogo. E pela primeira vez, trazendo uma abordagem de Zero Trust para a defesa do seu endpoint. Agora, você pode conter proativamente endpoints comprometidos, impedindo a movimentação lateral de ransomware com uma proteção que complementa seu atual detector de ameaças. Ao contrário do antivírus, que está procurando um ransomware conhecido, e da governança de rede, o Illumio Edge funciona através do firewall existente no sistema operacional dos endpoints. Você decide quais aplicações e serviços têm a permissão para se comunicar com a sua rede a partir de cada um dos endpoints. Isso é Zero Trust. Illumio Edge coloca você no controle. Apenas aqueles na lista podem entrar, sem nenhuma exceção. E se você não está na lista, desculpe ransomware. Você ficará de fora na chuva. Com o Illumio Edge, você fica à frente do jogo, criando políticas de forma fácil e enviando-as instantaneamente para todos os endpoints em sua organização. E o usuário não precisa fazer nada. A melhor parte é extremamente acessível, já que não há necessidade de mexer na rede. Mude o jogo com o Illumio Edge e veja sua empresa aparecer nos jornais apenas pelos bons motivos. E a proteção não é só para endpoints. É também para data centers e ambientes em nuvem. Todos sabem que vivemos num mundo onde tudo está conectado com tudo. Infelizmente, isso inclui hackers. É uma questão de tempo. O adversário habilidoso eventualmente entrará na rede. Sabendo disso, como você impede que ele se mova lateralmente em sua rede? Em uma palavra, segmentação. Então, por que não há mais pessoas fazendo isso? Porque fazer a segmentação com firewalls de redes é extremamente difícil. Pense nas frágeis regras de firewall. E ambiente em nuvem, então? O resultado? Políticas erradas, corrompendo seus aplicativos ou, simplesmente, nenhuma política protegendo seus workloads. Não seria mais fácil mover o controle da rede para os perímetros de negócio, permitindo que as políticas e proteções acompanhem os workloads e aplicativos? Bem, diga olá para o Illumio Core. É uma abordagem completamente diferente para a segmentação, onde você pode definir e fazer mudanças nas políticas sem se preocupar em corromper a rede, porque você nem tocará na rede. O Illumio Core utiliza o firewall existente no sistema operacional que você já possui e não o firewall ligado à rede. O cérebro do Illumio Core é seu mecanismo de cálculo de políticas, o PCE, que dá a visibilidade que você precisa para criar uma política clara, baseada em rótulos, escrita em linguagem natural. Simples assim, você pode construir, testar e aplicar políticas com base em critérios, não em adivinhação. Você pode ter a certeza que possui uma política de segurança consistente e controle em todos os lugares. E com Illumio Core, você finalmente terá a segurança que você tem procurado para acelerar seus negócios. Quando falamos em segmentação, só existe uma palavra a lembrar: Illumio.
I'm going to spend a few minutes discussing a common challenge on the journey towards micro-segmentation. One of the definitions of zero trust is that workload segmentation should be agnostic to network segmentation anywhere in the underlying fabric. If I want to segment my workload, I should not have to rely on network segmentation tools or hypervisor segmentation tools or segmentation tools in public cloud. I want to segment directly at the workload. So if I have one workload or 100 workloads, I don't want to have to figure out how to make 1 or 100 workloads down at the network layer. And what I want to end up with at the end is an allow list model, where at every single workload, I will allow only the traffic that I want, and I can block everything else. Now, these conversations are largely focused initially on what the fabric can provide. So if your workload resides in the data center, or if your workload resides in public cloud or in both in a hybrid environment, generally when these conversations start, we talk about how to segment there. Those tools, those environments exist to create segments, and the common starting point is let's use those. Now, if you have a data center environment, such as in the left side of this picture, these conversations go all the way from the bottom to the top, from the first layer of the OSI stack all the way to the top. So at the bottom, we generally have our spine leafs and switches. We have our hardware firewalls and other hardware security appliances, IDS, IPS, web caches, load balancers. And then we have overlay networking, which can reside either with an SDN controller or within a hypervisor. And we're going to be talking about things like VLANs and IP subnets and EPGs. We're kind of network centric. Or if we're hypervisor centric, we'll talk about NSXT security groups, VXLAN or Geneve segments, Nutanix flow. These are all networking and hypervisor conversations. But if we want to achieve a goal where every workload is sort of its own entity, and the boundary resides there, we have to abstract ourselves away from these conversations, because the two environments between data centers and public clouds are dramatically different. One major point is that in public cloud, the underlay network is completely hidden. So a lot of the options that we have, such as VLANs, are generally not available in public cloud. And those tools are focused on VPCs or VNets, depending on what cloud you're in, their version of security groups. You can have virtual firewalls. But again, we're still talking about network things. And networking tools are generally meant to segment for networking reasons. So the fabric is concerned with securing things like DDoS or ARP spoofing, whereas a workload is concerned with things like ransomware. And the networking tools, whether it's SDN or whether it's public cloud, generally have a different scale. So if your workloads, let's say you have 10 or 100 workloads, you might be able to create 10 or 100 segments at the network layer. But let's say you install Kubernetes on these workloads, and now you have a microservices architecture. now the sheer number of segmentable things can explode. And so now you have very large numbers that are probably bigger than the underlying fabric was designed to work at. So the question is really, where do we put security in this micro-segmentation conversation? And the goal is really, if we're talking about workload segmentation, let's put the solution there, directly at the workload. We want to make every workload its own distinct segment, and we want to be able to block and allow traffic there. And we don't want scale to be a problem. So if I have 100 workloads, I want to be able to create 100 segments. If I have 10,000 workloads or microservices entities, I want to be able to create 10,000 or far more workloads. I don't want to find out that my underlying tools max out at some number well below this. So the solution needs to reside at the workload, agnostic from the underlying fabric. And that means that we want some solution that sits there at the workload, some kind of agent that is ideally not sitting in the data plane, but in the management plane and coordinating all of these tasks somehow, but at the workload, every single workload distinct from every other workload, which means that I now should be able to deploy a workload, say spin up a workload in the data center and apply my segmentation solution there. And if I decide to move my workload from there into a public cloud environment, I should not be dependent on how that solution works. Okay, I should be able to move my workloads without reinventing the wheel. The first step, especially in the data center, is to create VLANs, the traditional three-tiered architecture where I have, say, my web tier, my processing tier, my database tier, assumes a legacy model of static workloads. Workloads that are web servers generally are assumed to stay in that VLAN, and the processing workloads stay in that VLAN, and the databases stay in that VLAN. But of course, in the modern workload world, VMs, vMotion, they live migrate often across layer 3 boundaries, which means that their IP addresses change. They now reside in a different VLAN. And if we are using traditional firewalls to try to process this, this rule or implement this model, this means that every time this happens, I have to touch the firewall. I have to somehow change or create very broad rules, broad zones that create environments in which lateral movement is very broad. So if one of my workloads gets infected with ransomware, I have a big problem. So we want to avoid this model, and we want to be able to identify workloads using something other than IPs and ports, because firewalls are traditionally, to this day, still dealing at that layer. This IP can talk to that port. This zone can talk to that zone. But if we can use labeling or some kind of metadata to identify workloads, we avoid the problem of workloads and IPs changing and having to change our security tools. Metadata applied to a workload means that that identity, that metadata, is associated with that workload throughout its life cycle. So that workload may have 10 or 20 different IP addresses in its lifetime, but the metadata stays consistent. And if I can now identify my workloads that way, I want to be able to write my policy that way. So I want to be able to sort of move the security model, the identification model, away from the network into my workloads, and I'll write policy that way, which frees up my networking tools to do networking things. So if in the left side of this diagram, this is a traditional hardware network with switches, and I'm trying to define lots and lots of ACLs, I can fill up my TCAM. If this is a cloud environment, I will hit a scaling limit because the security groups, for example, were not meant to identify 10 or 100,000 workloads distinct from each other. So using metadata to identify workloads and to write policy or segmentation using that metadata frees up workload segmentation from using network segmentation tools that were not designed for that task. So if we use a metadata-driven approach, we start the micro-segmentation journey, the workload-centric micro-segmentation journey with workloads. And I want to be able to segment them. But the question is, do I have enough information to start? I know what the end state is. I know what my goal is. But do I understand exactly how my applications work? I want to be able to create a segment at every workload. I want every workload to be agnostic to every other workload. I want to be able to define an allow list between them. And I can start by labeling them. So in this example, half of my workloads are production and the other half are development, and I can label them accordingly. But do I know what the dependencies are? Do I have enough information here to define what ports to allow and what ports to block? Often the answer is no. I don't exactly know what the behavior patterns are and what the dependencies are. Now I can go and ask my application team who have deployed my applications and ask them. However, often they may not know. The people who code the applications will usually know, but coding applications and deploying them and managing them are generally two different tasks. So a lot of enterprise applications, for example, will be a collection of off-the-shelf tools mixed with open source tools grabbed from GitHub and put together to solve a problem. But these are generally not the same teams that coded those tools. So we have to somehow be able to collect that information, which can range anywhere from turning on NetFlow on my hardware devices or putting VRNI in my hypervisor and collecting information and just trying to figure out and watch and collect analytics to learn. Now, does this mean that I have to wait to segment until I have that information? Let's say that process takes me a few weeks or a few months. That means that I'm exposed for that time. I'm wide open, and I run the risk that if I get infected with malware, I have a big problem before I've started any segmentation at all. So what we can do is create some kind of boundary initially and use sort of a stepping stone approach. Can I create some boundaries up front as I collect this information and then fine tune it going forward? So if I identify my workloads, I should also have a choice. I can use the labeling method to assign metadata to each workload. I should also be able to identify them using FQDNs, which is a common way of referring to workloads, or I may use IP lists. I may know that all of my development servers are using one range and all my production are using the other. I should have a choice for how to identify these workloads. And I want to be able to start by creating a broad boundary at sort of a business layer. I know that my dev servers should not talk to my prod servers, but I don't know how this works. But I want to have a tool that can divide these from each other in sort of a declarative model. I want to be able to say, hey tool, like, hey Alexa, I want a boundary between these two labeled workloads. I do not want to have to worry about rule order like in a firewall. So a firewall can implement a rule. Let's say these are two different IP lists, and it can define a rule that says anything beginning with 10 dot whatever cannot talk to anything with 192.168 dot whatever. And then maybe I have a few exceptions, like I want RDP to run through these, and then I can insert that exception in the firewall above that first rule, and that works. But now I have another exception and maybe another boundary, and where do I put that? And I run the risk of breaking things because rule orders and firewalls are generally read from top to bottom. So I want to not have to know that. So I want to be able to ask the tool, please create this boundary. Now, Illumio calls this an enforcement boundary. It's basically a wall, and you define it between your labeled workloads or however you identify them. And now, if I want to create some exceptions, I'm punching holes in that wall. So after I've asked the tool to create the boundary, I now tell that tool that, okay, now I want to make some exceptions. So I want to allow SSH and RDP from, say, my dev environment to my prod environment. I want to be able to choose the direction of this, so it can either be one way only or bidirectional. But this means that my allow policy now will override the block ports for that part of the wall and leave the others intact. So while we are talking about an allow list destination, what we're doing is using a deny list tool on our way to an allow list. So it's meant to be a temporary solution. So the idea here is to start using a deny list. And once we collect the information that we need, we then tear this down. So it's like a scaffolding that protects us as we're building. And once the building is complete, we remove the scaffolding. And again, I should be able to implement this without fully understanding what the dependencies are. Now, I should also be able to create more than one kind of a boundary, one kind of a wall. So in my first example, I have defined a boundary, a wall between my dev labeled workloads and my prod labeled workloads. But maybe half of these collections of both workloads reside in the US, and those workloads need to comply with US regulatory guidelines. But the other half of my workloads, both dev and prod, reside in Germany, and those workloads need to comply with EU regulatory guidelines. So I want to be able to create a second wall, which doesn't really interfere with the first wall. They both coexist, but sort of in parallel. And I can now write exceptions in this diagram from top to bottom between dev and prod, but also left to right. from one regulatory environment to another. And again, I should be able to do this without understanding all the ports and flows, but just telling the tool that, hey, I want one boundary for one set of workloads, and I want another boundary for another set of workloads, depending on how I identify them. Which means that if I now look at my application dependency map, I should be able to see all of my workloads and how they are behaving with each other. I want to ideally be able to look at this from a question of what workload is talking to what workload, who is doing to what, doing what to whom, but without worrying about IP addressing or what VLANs they're in or what EPGs they're in. I just simply want to see flows. And I also want to feel comfortable that there is a broad boundary between one set of workloads and another while I am collecting information and eventually tearing down this broad boundary. Now, some example use cases. The most common is probably this example of production and development. I have one environment where I'm creating tools and testing them, and then I want to push them out to production. But in no way do I want one environment to talk to the other unless I have a set of exceptions. So in this example, SSH or RDP. Another one would be, say, a corporate acquisition. So a parent company has bought a other company, and we don't quite understand yet what the tool behaviors are in the acquired company. So we want to be able to create a broad boundary between the parent and the child company, but we do want to create some exceptions. So in this example, I may want the tools used by my legal department in the parent company to be able to access, say, the legal tools in the subsidiary company in one direction only. Again, without knowing exactly how it works, I may just simply want to label my workloads or use the FQDMs for each, tell my wall, allow these through unidirectionally, but leave the rest of the wall in place until I complete the analytics collection process of my acquired company. I can define my allow list and then at some point tear down this wall. Another common use case for this, it would be dealing with ransomware. So ransomware is a big problem these days. And ransomware generally works consistently. The different types work in a consistent manner where one workload in an environment will be compromised. Then that ransomware will essentially phone home for instructions for how to laterally start infecting other workloads in that environment. So these are control ports, control channels for quickly spreading and infecting many workloads in an environment in which east-west protection is not in place. So I would like to create a boundary around every single workload. I want to be able to create an enforcement boundary or a wall between every workload, telling each workload that you may not talk to any other workload, with one exception. I know that all of them need to talk to an LDAP server. So I will tell this wall, this boundary, that do not allow any traffic whatsoever between these labeled workloads, but allow the relevant ports for LDAP in and out as needed. But they can't talk to each other. So what this means is that in this scenario, the first workload that gets compromised by ransomware becomes the last workload that is compromised by ransomware, because we are blocking most ports between workloads. And this will significantly reduce the number of ransomware instances that can spread throughout your environment. So boundaries should not apply just to groups of workloads, but to every single one. This can also apply to individual protocols running between individual workloads. So let's say an edict has come down from the CISO saying no more clear text protocols allowed, such as Telnet. In no circumstance should that be allowed in my network. So I want every single workload to be prevented from running Telnet. Now, I don't want to have to wait to patch every single one of my workloads. I want to enforce this at the layer in which packets traverse the network. And I don't want even the network to enforce this. I want this to be blocked and allowed directly at the workload. So no packet shall be allowed out of my workload that is clear text. So a boundary should be able to do that. And in Illumio's case, the enforcement boundary allows you to create allow policies and deny policies sort of in combination. So I can create a boundary around workloads and specifically say that I want this boundary to block Telnet, but allow everything else. So again, this is a mixed a solution that mixes both block and allow, whitelist and blacklist together to a collection of workloads at every workload, or processes and protocols running at every single workload. So I should be able to be as granular as possible. This can also be applied within the DMZ. DMZs are often considered somewhat safe environments, secure from the enterprise network behind a firewall. However, generally one or some of the hosts in the production DMZ will have some access into the production environment so that images or data or information can be pushed out to it. And some malware will use this fact to compromise one workload into the DMZ, and then laterally traverse these workloads looking for that one portal into the production environment. So we want to, again, be able to limit east-west flows in a DMZ. So I should be able to create a boundary around each workload and control what they can do to each other. They can listen to the outbound traffic, so incoming web traffic will be allowed, but lateral movement between workloads is prevented. And I can still allow that one workload that has access to the firewall into production. But now this becomes very isolated, and it becomes far more difficult for malware to find that particular workload. Let's say you have a legacy environment, sort of an OT environment, where you have a mainframe, some centralized mainframe, or some type of industrial control device that you cannot deploy an agent on. So in Illumio's case, we are enforcing this boundary using agents, but many things do not support agents. This could also be the case in a cloud environment where you have, say, a serverless environment where you cannot put an agent. We should be able to create a boundary around that legacy environment, which has the effect of telling all the workloads that you may speak to that workload, but only using particular ports, and you may not talk to anybody else using any ports whatsoever. So this would be an environment in which this boundary would remain in place unless that mainframe somehow is able to, in the future, support agents. We want to keep this boundary, this wall in place to give us a sense of peace that this mainframe, this legacy device is secured without being able to put a workload security solution directly on that. So if we zoom back out to the points that we need to keep in mind with this idea is that a wall or an enforcement boundary, which is a term Illumio uses, is a declarative model. You should be able to tell the tool what you want, define the end state, and then the tool will figure out how. So it's sort of like the Alexa model. Hey, Alexa, or hey, Illumio, I want to divide all my dev from all my prod, and that's it. And then the tool should figure out how to implement it for you. These are then overridden by specific normal allow policies. So as in the example, if I now want to allow RDP or SSH, if I write those policies and commit it, those now essentially punch holes through that wall, through that boundary, but leave the rest in place. And these should be directional. So I should be able to allow one way or the other way, or bidirectional. And again, this is specifying what cannot happen. This is a use of a deny list model as we are building an allow list solution. So the boundary, the enforcement boundary, is essentially a deny list, a broad deny list defining what cannot happen, with the exception of the holes that are punched through it. And as we identify our workloads, we should be able to do that in a number of ways. So I want to assume that my workloads will probably change their IP addresses, their individual ones. But if it's an acquired company, for example, I may know what the IP list is, the broad IP CIDR block for that customer. So I should be able to define that as a boundary, or maybe the FQDNs as a boundary, or label groups. I should be able to have a choice when telling this boundary or this wall what to separate. Now, this is most often used in brownfield deployments in which environments already exist. If you have the luxury of a greenfield environment where you are spinning up workloads for the first time, you probably have an easier time discovering how these tools interoperate and what their dependencies are. But the grand majority of environments will already exist, and the solutions need to be implemented now. Ransomware may have been a huge problem, and I want to prevent it from happening again. I want to be able to deploy this now in my existing brownfield environment. And again, it's meant to be temporary. So most cases, this will be a scaffolding, allowing you to take some baby steps creating a boundary up front while you collect your analytics to figure out what the dependencies are, and then tear down this concept. Or in some cases, you may leave it up permanently. So in the example of an OT environment or a mainframe environment where you have a device that you cannot deploy the workload-centric solution directly at the workload, the scaffolding will remain in place indefinitely. There's no reason why you can't leave it in place, but realize you now are using a deny list tool, even though you have implemented broadly an allow list architecture. So now you have some solutions, some choices to start your journey toward microsegmentation without running the risk of exposing yourself for too long while you collect the information and then implementing at the end. We want to be able to take baby steps. We want to be able to create scaffolding, and enforcement boundaries is Illumio's solution to this tool of allowing sort of a wall to be built up front and then punch holes, and then eventually have your full zero trust micro segmentation solution implemented directly at workloads, every workload at scale.
Well, very good. Thank you so much for walking us through the segmentation strategy. I'm sure we got some great questions, and you'll get some more back at your virtual booth. Meanwhile, attendees, thank you so much for being with us for this session. Please remember, give us feedback on the speakers, on the topic, what you'd like to see at future events, and enjoy the rest of today's summit. For Information Security Media Group, I'm Tom Field. Thank you so much for your time and attention.